All right, and our last topic here in today's series of measures of center and measures of variability is a final measure of variability called mean absolute deviation. That sounds pretty complicated, okay? But it's not really that complicated. Okay, so mean absolute deviation is a measurement, again, that you have with a set of data. Okay, and what it is it takes the mean of the data, the average, and then you find the difference of every data point to the average. Now you find the absolute value of those differences. So you don't worry if it's positive or negative. You just find how far off all of your data points are from the mean. You add all those differences together and divide by how many there are. And that gives you what's called the mean absolute deviation. And again, it's a measure of how far all of your data points are from the average of all the data points. So in the book, the calculations look very complicated because they write out this absolute value subtraction for every single data point. Now, I think in general, I know for me, I just do all those subtractions in my head. So I'll explain to you what I mean here. So the first thing you have to do to find mean absolute deviation is to get the mean of the data set. So you add up all the numbers and you divide by how many there are. So this is basketball points scored in the last 7 games, and the average points is 18 points per game. Average. Add up all the points, divide by the 7 games. Okay, so to find the absolute value, to find the differences for each point, you subtract the value of each data from 18, or you subtract 18 from the numbers that are bigger than that. That's why they use absolute value, right? You don't use negative numbers here. You just find the absolute value of the difference. So just subtract the bigger number minus the smaller one, and that will always give you this positive number. So 17 from 18 is 1, 22 is 4 away, 17 is 1 away, this one is 12, this one is 3, this one is 1, and this one is 10, right? So all these answers here that they show these subtractions for, you don't have to show these subtractions. You should just be able to list all these numbers out, doing them in your head. Now, sometimes when there's decimals involved, it's a little more complicated. You'll see that in the next example. But finding all these differences and writing them all down, you can do that in your head. Then you take all those differences and you add them all up. You're going to find the average difference. Okay, so you add them all up, you divide by how many there are, which is the same as how many data points there are. And your mean absolute deviation for this is 4.57, which means that the average number of points that this guy the points that this guy gets per game on average are within 4.6 points of his mean points per game. Okay, so you'll use average twice here. It's the average difference of the points and the average number of points. Okay, so you have the mean of the data, which is your center point, and the average difference of all your data points from the center is your mean absolute mean absolute deviation. Okay, it is again a measure of how spread apart your data points are. Okay, all right. So here's an example to do, which we can kind of go through together. 5 boxes of tomatoes have 18, 21, 16, 19, and 20 tomatoes in them. What is the mean absolute deviation, and then what does it mean? What does it represent in this situation? So first, calculate the mean for these 5 boxes of tomatoes. What is the average for these 5 boxes of tomatoes? 18.8 is what you get. Add them all up, divide by 5. Okay, now you need to find all the differences. So 18.8 is the average. What is the difference for each of these numbers from 18.8? And again, I do these subtractions in my head. You can as well. 18.8 minus 16 is 2.8. Then 18.8 minus 18 is 0.8. Then we go the other way. 19 minus 18.8 is 0.2. 20 minus this is 1.2. And 21 minus 18.8 is 2.2. You'll see that these decimals will always end. The lower ones will end in this decimal, and the higher ones will end in the same number also when you subtract them, if they're all whole number data points. Okay, so here's all my differences. 2.8 less, 0.8 less, 0.2 more, 1.2 more, 2.2 more. Okay, it doesn't matter whether they're more or less. I just take all the differences, positive numbers, absolute values, and I add them together and divide by how many there are. So what is the mean absolute deviation? Add them all together and divide by 5, and your answer is 1.44. What does that mean? What does it mean that the mean absolute deviation is 1.44? It means that for these boxes of tomatoes, they're all within about 1.5 tomatoes of the average amount in a box. Right? Each box is within about 1.5, is that the average difference of the boxes from the average box is 1.5. All right, and you can also use mean absolute deviation to compare different data sets to see how their variations are different. Okay, so there's a lot of gobbledygook here in the book on this particular example, which I've kind of squeezed it together. Okay, there's girls' heights and boys' heights. Now, this is a dot plot, which we will talk about more on Tuesday in the next class. Okay, you should be able to read the dot plot, that each dot here is one of these data points. And so to find the mean, you have to add all of these things up. 59 plus 61 plus 62, 63, 64, 64 plus 64 plus 67. So you do all that here, divide by how many there are, and find the average, the mean. Okay. Then they calculate the absolute difference, the absolute value of the difference for each data point. And again, you can do that in your head. The average is 63 here. The mean is 63. So that's 4, 1, 1, 1, 0, 1, 2, and 4. That's all these answers here, the differences between each data point and the mean. Then you add them all together and you divide by how many there are, and you get 1.75. On the boys' side, the mean is 65. Your differences are 5, 4, 3, 3, 1, 0, 7, and 9, right? All these subtractions you should be able to do in your head. Add them all together, divide by how many there are. The mean absolute deviation on the boys' heights is 4. So compare these two sets of data. What does the mean absolute deviation tell you? Well, it tells you that the boys' heights, there's a lot more variation, okay, in the boys' heights than there are in the girls' heights. The girls' heights are much closer together. Less variation from the average than the boys' heights. That's what that mean average deviation tells you. All right, so one last one for you to do here that's not already done in the book. These two dot plots show high and low temperatures in Denver during 1 week at some time. Temperatures are pretty high, so it must be in the summer. What is the mean absolute deviation for each set of data, rounding to the nearest hundred? So a lot of decimal work here. Then compare the variations. First, calculate the average for each temperature, set of temperature data. What is the average for the high temperatures? Should get, if I did it right, 78.29 degrees. What is the average for the low temperatures? Add up all 1, 2, 3, 4, 5, 6, 7 of these and get 48.71 degrees, your averages. Now you need to find the absolute value of the differences between each data point and the mean. So 78.29 minus 68, 10.29, minus 74, 4.29, minus 76, 2.29, minus 78.29. Now we're going the other way. 81 minus 78.29 is 4.71, then 5.71, and finally 6.71. That's these 3 points here. Okay, so you've got all your absolute values of differences. Do the same thing on the low temperature side. 4.71 below, 0.71 and 0.71 for the 240. Then they're 0.29 higher, then 2.29 higher, and 3.29 higher. So these are all your differences between the data point and the mean. Now you find the average of each of these. Add them all up and divide by 7. You should get 4.81. add all of these up and divide by 7, and you should get 1.76. Those are your mean absolute deviations. 4.81 for the high temperature data, 1.76 for the low temperature data. So what does this tell you? That the high temperature variation is over twice as much as the low temperature variation. You could say, how much specifically, okay, but much more variation in high temperature, differences from the average than the low temperature. You can see that these are all spread out, and here there's like a little clumpiness of those, which makes the average difference much closer, much lower. And that's just an analysis of the data. All right, so that's mean absolute deviation. The numbers that you have in the IXL topic for this one are hopefully not too difficult to do. Low amounts of numbers, easy, low numbers to do to calculate mean average absolute deviation. And then we'll look at all of these things together in some real world applications in the next class.